Let us see the relation between gx and hx in case of the cyclic code. So x raised to n plus or minus 1, we can write it as gx and hx. That means gx and hx are the factors of x raised to n plus 1 or minus 1, because in mod 2 plus 1 is equal to minus 1. So either you can write x raised to n plus 1 or x raised to n minus 1. We are writing further as x raised to n plus 1. So for n comma k cyclic code, gx and hx are the factors of x raised to n plus 1. Now we already know that gx has the degree n minus k. If it has the degree n minus k and here it is n, that means hx should have the degree k. So n minus k plus k is equal to n, this n. So hx has the degree k. hx is called parity check polynomial. Gx is called generator polynomial. Now if you divide x raised to n plus 1 by hx, you will get the gx as quotient and remainder equal to 0. And if you divide it by gx, you will get hx as quotient and remainder equal to 0. And one thing is that gx and hx both are monic. Monic means its leading coefficient is equal to 1. That polynomial's leading coefficient is equal to 1. What is leading coefficient? Is the coefficient of the highest power term. Any polynomial, we know that any polynomial or any code word in cyclic code C can be written as message polynomial into generator polynomial. Cx is equal to mx into gx. If you multiply this with hx, that is parity check polynomial, cx into hx is equal to mx gx into hx. That means this equation we have multiplied with hx, here also hx. So cx into hx is equal to mx into gx into hx. Now gx into hx in code C is equal to 0. Gx into hx in code C is equal to 0. What does this mean? That means you have to remember that all the polynomials in code C are obtained as mod x raised to n plus 1. All the polynomials in code C are obtained as mod x raised to n plus 1. That means those are the reminders. All the polynomials are reminders of reminders obtained after dividing by x raised to n plus 1. So we will see it further. So what does it mean? Suppose this is a polynomial fx, any polynomial, for example x cube plus x plus 1. So what is monic? Monic, first I will explain. Monic is this is the highest power 3 in this polynomial, which is called degree also. So it becomes the leading leading coefficient or leading term, we can say. Its coefficient is 1. So this is a monic polynomial. Okay. Now in C, you know that there are polynomials, because cyclic code can be represented as polynomials as well as in terms of bits. Now in C, what is the feature of these polynomials? These polynomials are nothing but the remainder. These are reminders obtained by dividing fx, any polynomial, by x raised to n plus 1. So this you always remember that C is a code set of polynomials which are nothing but these C is a, suppose polynomial 1, polynomial 2, likewise. So this is a code set. Now what is the speciality of this polynomial? What is the feature of this polynomial? This polynomial is nothing but a remainder of any polynomial obtained after dividing it by x raised to n plus 1. Or C is a code set of polynomials which is nothing but the remainders obtained after dividing it by x raised to n plus 1. Okay. Now x raised to gx into hx is equal to x raised to n plus 1. But in code set C, x raised to n plus 1 is any polynomial is nothing but obtained as a mod x raised to n plus 1. Or any polynomial is nothing but a remainder obtained after dividing it by x raised to n plus 1. If you divide it by x raised to n plus 1, you will get the remainder as 0. So in code set C, gx into hx is equal to 0. So cx into hx is equal to 0. First we have seen, what we have seen, that x raised to n plus 1 is equal to gx into hx. But in code set C, this gx into hx is equal to 0. Because if you divide this polynomial by x raised to n plus 1, you will get remainder as 0. So what we are observing here, that any valued code word, if you multiply it with the parity check polynomial, you will get answer as 0. So that is one check to see whether the code word is a valid or invalid. So that is used further for the error detection in cyclic code. So the same is written here. Why that gx into hx is equal to 0. Although gx into hx is equal to x raised to n plus 1, but in cyclic code we have to divide it by x raised to n plus 1 and take its remainder, which is equal to 0. So from this we can see that we get one parameter, that parity check polynomial can be used to detect whether the code is correct or not. If it is code is correct, then you will get the multiplication equal to 0.